All right, today we're going to be talking about the speed at which things heat up and why different things heat up or cool down at different rates. All right, so we've talked about dark versus light surfaces already, and we know that dark surfaces heat up faster than light surfaces. And you probably know this from experience living out in the world. In the summer, if it's really hot out, you don't want to wear a dark shirt because you'll get extra hot. But how about this scenario? If we have a metal cup and we have a styrofoam cup, which one would you want to put coffee in if you wanted to keep your coffee hot for longer? So if you wanted to keep your coffee hot for longer, you would put your coffee in the styrofoam because it is an insulator. Metal is a conductor, so that means it pulls in and gives off heat really, really fast. While styrofoam, the insulator, doesn't give off heat very fast and it doesn't take in heat very fast either. It's kind of like this metal versus this cork. The metal in my hand, when I hold it, it feels colder and the cork feels warmer, but really they're the same temperature. It's just that the metal takes my heat in faster than the cork does. And it would be the opposite. If we heated both of these up and made them really, really hot, the metal would feel even hotter than the cork, even though they're the same temperature. It's just that the metal gives off or radiates its heat a lot faster than the cork does. So, what we say is that metals have a low specific heat, which just means that they heat up fast and they cool down fast. A low specific heat just describes the amount of energy needed to change an object's temperature. So, the amount of energy that water needs to change its temperature is a lot higher. It's 4.18 compared to something that's metal, like iron, copper, or lead, which are all 0 point something. They're all small decimals. So all this means is that the metal needs a small amount of energy to change its temperature, while liquid water needs a lot of energy to change its temperature. You've probably experienced boiling water before. When you boil water, it takes a long time for that water to reach its boiling point. It takes a long time for it to heat up. And that's because water needs a lot of energy to heat it up. While something like a copper pan, a metal copper pan, it'll heat up on a flame like that, like super, super fast. And that's because it doesn't need much energy to take in order to heat up. So, high specific heat heats up and cools down very slow, while a low specific heat heats up and cools down really fast. So that's another general rule. If something heats up fast, it also cools down fast. So iron, copper, and lead, these things heat up fast and they cool down fast. While water, if you have a hot cup of coffee, it took a long time for that coffee to get hot because it has a high specific heat. But that coffee will stay hot for a long amount of time because it also cools down very slowly. So if you heat up slowly, you also cool down slowly. All right? So this is on page 1 of the reference table. Another thing that we need to talk about is smooth versus rough surfaces. We already know that dark surfaces heat up fast, while light surfaces heat up slowly. Or dark surfaces absorb energy fast, while light surfaces reflect energy. But in this case, a rough surface is actually going to absorb energy faster than a smooth surface. While what that really means is that the smooth surface is going to reflect energy. So you can think of like a mirror. A mirror is a very smooth surface and you see your reflection in it. So smooth surfaces reflect while rough surfaces absorb energy or absorb light. Okay? So, why do we use metal pots and pans? Why do we use metal for that? The main idea is that metal heats up really fast and it cools down really fast, so it can heat up our food really fast. Why does water take so long to boil? It has a high specific heat. Water has a high specific heat, so it heats up very slowly. What can cool things down faster, metal or wood? Metal is able to cool things down faster because it has a low specific heat. It's able to absorb energy really, really fast, which makes it cools things down. And what can heat up things faster, metal or wood? Metal can heat things up faster. So what cools down faster? Metal. What heats up faster? Metal. All right, so this is going to be here on the reference table, and the main idea is to remember that a high specific heat heats up and cools down slowly. A low specific heat heats up and cools down very, very fast. Okay, cool. So these are all those objects. This is water. We've got water vapor. We've got ice. Those are the three things that are on the top of the specific heat, right? So we got liquid water, solid water, which is ice, and water vapor. And then we have dry air, basalt, granite, iron, copper, and lead. Just so you can see what these things actually are. All right? So like we said, a high specific heat, things heat up and slow down and cool down very slowly, while a low specific heat heats up fast, cools down fast. All right, so main idea here. Water has a higher specific heat than nearly everything, meaning that water heats up almost slower than anything in the universe, and also cools down slower than anything on the universe. So water wants to remain the same temperature. So water has a high specific heat, so it maintains temperature really, really well. It holds temperature for a long amount of time without changing. So here's just a random question that we can try. There are 4 materials listed on here. These 4 materials were left out in the sun for 24 hours from midnight here to midday, and then all the way back to midnight the following day. Based on the rate of heating and cooling, which line belongs to each given material? Okay? So we know that the thing that heats up the fastest has the lowest specific heat, while the thing that heats up the slowest, right, this red line heats up the slowest, it has the highest specific heat. So what we have here is the highest specific heat is going to be liquid water, while the lowest specific heat is lead. So if we look at this graph, the one that changes its temperature the least has the lowest specific heat, so that's going to be liquid water, while the one that is the lowest specific heat is going to be copper, and that heats up the fastest. All right, so that's specific heat for you.